Okay, so welcome everyone to the 2020 EPAC Groundbreakers Virtual Tour by EPAC OUZ. This year, our event would be the biggest one ever done, with 174 sessions, including normal sessions, workshops, and hands-on labs, and from 123 different speakers over 11 days. Also, it would cover sessions on 4 different languages. And please remember to register to as many sessions as you can, and all sessions would be available to replay as many times as you want for 2 weeks after the initial date and time. And you can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page. First, I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. And now for today's session, Introduction to Java 15 by David Buck. Please feel free to write questions at any time during the session at the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If any questions during the presentation, please feel free to contact me at any time in the chat tab of the Zoom webinar. And now, without any more delays, I would like to leave you with this amazing session by David Buck.
Hi there, just give me a second to share my screen. So, all right, well, happy Monday, everybody. I'm really excited to be here virtually and to be talking about Java 15. So just to get this out of the way, so this is content that was already delivered by Chad Schratt and Aurelio about a month ago, I think, or a little bit earlier than that, during their monthly webcast. But because we have a little more time than they had when they originally delivered it, we can kind of get into a little more technical detail this time around and kind of make the content kind of more focused on the propeller heads in the audience, if any of you are out there. So we have let me go ahead and start the presentation. There'll be no demos today. This will be all slide content for today's session. So the standard Oracle Safe Harbor statement. Normally, I don't make too much of a big deal about this because usually I'm talking about things that are already kind of out the door and shipped and released. But by their very nature, some of the preview and incubator features that we're going to talk about that are included in JDK 15, but won't necessarily make it into future versions in the form that we have them as a preview today. So you have to be careful about when you're planning things or what your expectations are regarding future versions, because some of the features that we talk about won't necessarily look the same way or work the same way when they make it into the future product, if they ever do. But I'll be very careful to point those out and make it clear that we're talking about a preview feature that's not intended for production use yet. So this is a really exciting time for Java, really exciting year. Obviously, a lot has been going on, not all of it necessarily good or wonderful, but an adventure nonetheless. The big thing is that this is the 25th anniversary of the Java language itself. And so we've been able to take some time to look back, see what we've accomplished the past 2.5 decades, and kind of make plans and think about the roadmap going forward for another really great 25 years. Where we are today is that Java still is really the most popular programming language in the world. It's still people's go-to choice. Really, the promise of Java, which from day one has always been write once, run anywhere, still holds true today when we're thinking about the cloud. So, components and code and software that you wrote, maybe decades ago, still, kind of work and are just as valid to use in cloud environments and modern hardware and frameworks and whatnot as they were when they might have been written considerably further in the past. And so Java kind of still delivers on that promise of making the investment that you put into it in terms of your skills and your effort and your time, and making that pay off years or even decades later by continuing to innovate and make the runtime work on more platforms, work in more environments, work more efficiently, give you better performance, even with the same code. So we're still doing a really fantastic job, and we're looking forward to another great 25 years ahead of us. So what really drives the success is that Oracle really is the open and the free language that we love and use today, and will continue to be. And so we're continuing to kind of deliver on covering more use cases, trying to continue to focus on developer productivity and compatibility, like I stressed on the previous slide. And we do so in a way that's really open and transparent to everybody, because all of our work is done in the open, as open source projects. There's no surprises or shocks, right? Like everything that's coming along in the pipeline, you have an opportunity not only to see it ahead of time, but to actually get your voice heard and take part and contribute, whether that's in the form of bug reports or feedback, or maybe even delivering code and things like that. You can really participate in the process as much as you want to, and that's really unique and exciting in the world of IT and programming languages. It's one of the reasons that Java has been so successful up until now, and we have no plans to change that going forward. So what is new, or relatively new, is that in 2017, we moved from doing what we would call feature-driven releases to time-based releases. So previously we had these kind of monolithic releases where there were certain, kind of absolute must deliver features that really drove the timeline. And so the timeline for release was modified as needed to fit when the features would be deliverable, would be finished. And we've gone from that to having a much more predictable, kind of clockwork release pattern where 2 times a year, March and September, there's a major feature release of the Java platform. And this makes a whole bunch of things work smoother and easier. For people that are anxious to get access to the latest features, you don't have to wait, every 3 years or even longer for the next, major version to come out. You can get your hands on them much, much sooner. But it also makes things more manageable. The pipeline is much more, at a much more easier pace to keep up with and keep on top of things, because you're not just given these huge monolithic things with a whole bunch of changes. You can kind of adopt new technologies and new techniques piecemeal. So Java 15, which was released last month, is the 6th of these new time-based releases that started with JDK 10. And you can see right now we're kind of in between our long-term support releases, the last long-term support release being JDK 11, and the next planned long-term support release being JDK 17, which we plan to ship next year. So as I said, by moving to this new time-based release schedule, we have a much easier time kind of keeping up with the amount of change. So kind of the unit of the work that we do on the JDK is known as a JEP, right? A Java Enhancement Proposal. And previous versions could have 50, 90, even 100 or more JEPs associated with them for all the different new features and APIs and changes that we're putting into the product. Now we have a much more manageable pace where there's still a lot of change going on, but because you're getting it piecemeal, you can adapt with the throughput is much more reasonable for people who are consuming updates to the Java platform. Also, another big change is that we've moved to a subscription model for our support offerings, and this is a much simplified, kind of more accessible form of support than perhaps a lot of people are used to consuming from a Fortune 500 company. And so we've had amazing success. There's been a lot of excitement around our subscription model. And I mean, we're seeing people buy support, all the way from, Oracle's bread and butter Fortune 500 customers down to individual Java developers who are privately, buying subscriptions with their credit card on the Oracle store online. So it really is a different different type of support than Oracle's ever really offered before, and it's proven to be very, very popular with our users. So if you're looking to, if you're using Java in production and you're looking to kind of get support from the people who make Java, really we offer the best support options available. So this is the main gist of today's talks. We really want to focus on our last month release, JDK 15. So we've broken down the JEPs here into several different areas. Technically the main new features look like it's only the EDTSA edition and hidden classes, but there's a whole lot of other really exciting stuff happening. Specifically in the runtime, we have 2 new garbage collectors that have made the jump over from experimental status to full support, full production support. As of this release, we are able to use text blocks in our code, which we'll see some examples of in some upcoming slides. And there's also a whole lot of preview technologies that are included in the 15 release. And we'll dig down into a few of those in the slides too, because there's a lot of really exciting stuff in that pipeline. And finally, we've also done some housekeeping stuff where we've either deprecated some technologies that we will probably remove some point in the future, and we've also removed stuff that had been deprecated in the past. But today, just because of the amount of time that we have available to us, we really can't dig into anything in too much detail. And so anything that you're interested or excited about, I highly encourage you to go and check the actual JEP text, which is available online. So you can see the URL in the bottom right-hand corner of the slide, the openjdk.java.net projects JDK 15, and that has a list of all the JEP documents, and they're really easy to read. They're not really like specifications. They're more aimed at kind of end users to be able to read and understand. So it's fairly easy to just kind of pick one up and read through it and understand all the nitty-gritty details of any particular new feature that you might be interested in. And they also contain pointers to other information that might help you ramp up on any of these new technologies. So I highly encourage you to go and check out the JEPs that kind of give you the full story for each and every one of these new features. So I'm jumping right into the feature list. The first thing is the EDTSA, which is basically a response to the speculative execution vulnerabilities that were, kind of had us all losing sleep a few years ago. So we had these side channel attacks that were based off of the idea that, even if, something's protected behind a branch or something like that, that modern CPUs will speculatively execute code anyway. If an attacker, for some reason, through a side channel, is, say, for example, watching the behavior or can infer the behavior of the instruction cache, they might be able to infer which branches were taken, even if they should have, no visibility into what your particular thread of execution is doing. And so what this new technology does is it says, hey, we've got this really secret information that we want to keep from the rest of the world. So if branches are a source of leaking information, then the key here is not to branch based off of the secret information. So there's obviously still going to be branches in the code. It's not all straight through. But by making sure that we don't have conditional branches that are conditioned on information that we want to keep secret, we can better ensure that will keep that information from prying eyes. And so it's kind of an amazing technology that I don't think many of us really anticipated a few years ago, but that's available and it's being introduced. I do want to point out that this is not at this point integrated into the JSSC TLS 1.3 implementation, but that is something that is on the roadmap for a later future JEP. We also have hidden classes. This is more of an implementation detail for, say, like language runtimes and things like that than anything that most end users would be too familiar with. But in a nutshell, a lot of language runtimes will have a need to dynamically, at runtime, spin up bytecode and create their own classes that are used to instantiate different things. So for example, the textbook example is even within the Java language itself. are implementation of Lambda functions. Java C doesn't compile Lambda functions into static classes that sit on your disk or anything like that. They're actually generated in memory dynamically at runtime. And so when we do that, any classes that we create that way are very obviously just for internal use by our own implementation, and there's no expectation of anyone outside of the language runtime actually using those classes. But unfortunately, up until now, we've had a situation where when you dynamically create classes like that and load them by your class loader, those classes are visible to anyone else that is using that class loader to load classes. They can still pull them up and do things with them. And so when your intention was really just to use reflection to manipulate and use these classes internally, and you're exposing them to users that you didn't mean to expose them to. So hitting classes gives the runtime creators the ability to say, I want to create a dynamic class, but I just want it for my own usage. I don't want to make it visible to anybody else outside of the static class. So we have a scope there that allows us to compartmentalize and prevent other people from misusing a class that was never intended to be visible outside of our implementation. And it also helps us with memory footprint because we have better control now over when those dynamically generated classes would be eligible for collection after we're done using them. Whereas in before, they would just kind of have the lifetime of the class loader that loaded them by default. And the motivation here is that there's actually a method under Sunmist Gunsafe that allows you to do these types of things already, but of course it's not supported, it's unsafe. It's not something that we want people using. And so this is another example of us replacing an unsupported Sunmist Gunsafe API with something that's actually documented and supported and part of the spec, so that people can migrate their code to using actual supported parts of the Java platform. And so hopefully at some point we'll be able to deprecate and then eventually even remove the access to Sunmist Gunsafe. Okay, and the other big change that's not a preview change for most users is text blocks. And this is something that pretty much everyone should be aware of, because everyone writes code at some point where you have really long strings. This is something if you think of like here documents in shell scripting or something like that. This is going to be very similar, where you have string literals that cross several lines, and putting them into your source code or embedding them in your source code is just a painful experience. It's no fun at all. It's a pain to write, and it's even harder to read, which is even more important. And so an example really makes this clear. So for example, you've got this HTML and you want to embed that HTML for whatever reason into your source code file. And if you do that with the previous Java before the text blocks feature was added, you have to write something like this, because we don't really have any elegant way to allow a string literal to cross the boundary of multiple lines. And so you basically are stuck concatenating multiple lines together and manually inserting the line feeds. And it's no fun at all to write code like this, right? And it's even less fun to read. So text blocks allow us to use a new delimiter, which is the triple double quote, and basically say, everything between these delimiters is basically part of my text block, and I want you to use this string as is. And we can even say that, well, we want to be able to indent our string in a way that makes the source code easy to read, right? So if you look at the indentation here, it's obvious that this is all part of the same string literal that's begun at the line at the very top. But at the same time, in the string literal itself, we don't want those extra spaces. So part of this feature is that we can heuristically tell when we're compiling with Java C that, hey, this indentation to the left, what we see on the slide here as these dots, is really just to align the literal with the rest of the source code, and it's not meant to be a part of the literal itself. So we can distinguish between that. And in the same way, we also know and can assume that any white space after the last white space character not the last non-white space character on each line is probably also not something that we want included in the text literal. You know, we really just want the new line at the end of each of those by default. So that makes sense, and it's much easier to write and to read. We also have cases where, you know, maybe we don't really want multiple lines in the literal itself, but for readability purposes, you know, we don't want a 200 character single line in our source code. So we still have to break up the literal across multiple lines, even though we don't want any of those line feeds making it into the literal itself at the end. And so now with the text block functionality, again, using the triple double quote delimiter, we can sit there and say, hey, you know, I want these 3 lines included, and just like, you know, if we're shell scripting or anything else, we can just use a backslash to you know, ignore the line feeds or skip over the line feeds in terms of what actually makes it into the literal string. And finally, as I mentioned earlier, you know, we assume that any white space after the last non-white space character in a line was not intended to make it into literal, but there are cases you can imagine where you might not necessarily want that behavior. And so there's a new escape sequence that we've introduced that says, hey, you know, these additional white spaces, I want them there. I expect them to be there. So the \s, or perhaps if you're using, depending on your locale, that might look like a yen mark, but it's the same thing. This \s escape sequence will tell Java-C that, you know, yes, the additional white space at the end of this line actually does need to be part of the literal here. So this will really clean up and make a lot of the code that, you know, has these really long strings or multi-line strings much easier to read, easier to write, and easier to read. So moving on to what's new in the JVM itself, probably the biggest thing is the Z garbage collector. Now we've had it for a while, right? Like it was introduced in a Linux only form in JDK 11, and then back when JDK 14, we added official support for Mac and Windows. And so at this point, we have all of our main platforms supported, and we've also just done a ton of improvements and bug fixes, you know, to really stabilize and polish this feature so that it's finally production ready. So up until now, you've had to use the unlock experimental VM options flag to let the JVM know that, yes, I know what I'm doing. I'm trying to use this, and I know that's a dangerous thing I shouldn't use in production. And that's no longer the case. And so you can now use the Z garbage collection by simply just, you know, using the use the GC option on the command line, and you don't need to, you know, kind of use any scary options that say that it's experimental, because it's not. And so for people that are new to the Z garbage collector, it really is groundbreaking. It's amazing. You can run multi-terabyte heaps with pause times that are still, you know, in the single-digit millisecond range, and we'll look at some actual results in a second here. So this is just some arbitrary benchmarking that our ZGC people had done at one point. And what we're seeing here is pause times in milliseconds. So obviously pause times, you want them as small as possible. And, you know, we see parallel GC, G1 GC, and ZGC all compared here. And at a first glimpse, it seems like we forgot the ZGC numbers, right? But in reality, the ZGC numbers are so small that you just can't see them unless you magnify them. So if we multiply them by 10, then even if we're drawing them at scale compared to these other garbage collectors, we can kind of see them finally and and see how amazingly small. So we're talking about, even for very, very, very large heaps, sometimes our max collection time is not only just single digit, it can be under 2 milliseconds very often. So really groundbreaking change. That said, ZGC is not the default garbage collector. Our default garbage collector, which changed in JDK 9 to G1, is still G1. And there still are use cases where G1 is probably going to be your choice for which garbage collector you want to use. ZGC excels in very large heaps, meaning in the gigabyte range and bigger. And so if you have a small heap of, say, in the hundreds of megabytes, it might not be ideal to use that GC. G1 might give you better performance. There are also cases we've seen where by a few percentage points, G1 gives you better throughput than ZGC does. And so for throughput reasons, depending on what your performance tuning goals are, you might want to stick with G1. So we still don't have a one-size-fits-all garbage collector at this point. And it's an active area of research and engineering effort on our part. But ZGC is a very powerful new option to have in your tool belt. And so if you are using very, very, very large heaps and or looking for very, very, very small pause times for some sort of concurrent application, now would be the time to take a very serious look at ZGC, because it's not only part of the product now, it's fully supported for use in production. Also, similarly, the Shenandoah GC is no longer experimental. It's also made the jump over to production ready. And so, congratulations to our friends over at Red Hat who have done amazing work on that project. And we still look forward to see what exciting things they will do in the future with their GC. And now kind of an internal housekeeping thing. So we've re-implemented the Datagram Socket API. Now, this is not something that as the average Java developer, you should really need to be aware of. Anything more than we've changed some stuff under the hood. And so when you move to JDK 15, if you have kind of problems with UDP or things like that at the networking level, this might be one possible cause of changes in behavior. And if so, we've introduced a new flag that you can set a system property. This use plain Datagram's socket implementation, which basically falls back to the previous implementation, which is still shipped in the release. So there's a fallback available. So very quickly, if you notice a change in behavior that's causing problems or whatever, and you just want to identify that, yes, this is the root cause of the change, this makes it very easy in your troubleshooting efforts to kind of go back and see if the changes that we made under the hood are what are responsible for some change you might see in your application behavior. And this is not the first time we've made a change like this. So if you look back at JEP 353, which went into JDK 13, we made somewhat similar changes to the Java.NET Socket and Server Socket implementations as well. And both of these series of changes are actually primarily motivated by the same thing, which is Project Loom. So Project Loom is, of course, our effort to give you kind of these lightweight threads that are not operating system level threads, but user space managed threads, so that we can free the Java developer to use threads without worrying about the traditional overhead that comes with thread creation and usage. And so as part of that, there's a lot of code within the JDK itself that isn't exactly thread friendly in that sense, or lightweight thread friendly. And so it really needed to be modernized for us to be able to leverage Project Loom like we hope to do in the future. And so as part of our preparation for Project Loom, we've been doing a lot of work in the networking stack to kind of clean things up and modernize, and in cases like this, almost completely rewrite and replace a lot of the implementation so it's NIO based and modern and clean. And that will play much nicer with our Loom implementation whenever we finally get that. Okay, now we're getting into the preview or incubator type features that are included and are, in a sense, production ready in terms of quality. These are complete features. They're not like early access or beta or anything like that. But we are saying with a really, really stern warning that these may change, or they might not even make it into the final product in the future. So while they're there, and we hope we've polished them very, very well, we still want to leave some room for possible changes in the future before we really nail down these specifications and write them in stone to where we're stuck, being compatible with them until the heat death of the universe. And so These preview functions, I want to encourage everybody to play with them, experiment with them, see what's coming up, and probably most importantly, give us feedback. And so if something doesn't work the way that you would like to see it work, or that seems less than ideal to you, join the discussion on the OpenJDK mailing list. Let us know what problems you might run into or where you see room for improvement. So the first one of these preview features is sealed classes. And sealed classes are really cool because it's an issue that to some extent has been with us. It's really the 1.0 release of Java. And it's kind of a design level thing where if you as a component or API or whatever provider who's writing code that other people are going to consume, you might want to have more fine-grained control over who can extend some of your classes. So for example, if I'm writing a financial application and I might have like a loan superclass, and then I might have several different types of loans that are subclasses, that might be a very natural part of the domain that I'm modeling. And whatever API I'm offering to my users, it might make sense that I might want them to be aware of and to be able to work with that model, meaning that they would use the superclass, they would know what the superclass is. I wouldn't be hiding anything from them. So I want to give them access to all those classes in the hierarchy that I've created, but at the same time, I don't want them to be able to extend any of those. And until sealed classes, there was no real easy way to say that, yes, I want this hierarchy to be visible and usable to people outside of my package or my module, but at the same time, I don't want them to be able to extend it. So sealed class lets you explicitly say that, yes, only these subclasses that I explicitly list here are eligible for being subclasses of this particular superclass. So it gives you a way of exhaustively listing all of the classes that you expect to implement your particular interface or extend your superclass. So it's it really gives us a lot more control over our interfaces, and it also lets us do really neat things. This plays really well with say records that we're going to talk about in a few slides. So if we're doing things like pattern matching records, and we're pulling them apart and stuff. But if we're dealing with a sealed class, we kind of have a guarantee that there are no cases that someone else added to our class hierarchy after the fact that we might have to contend with. So in many cases where you would assume you would need, for example, a default case when you're pattern matching, because other people might have extended your superclass without you knowing or necessarily wanting that to happen. Now you can basically prevent them from doing that. So we're going, all the way back to like the first edition of effective Java, where we're saying, when you design classes, you either design them for extension or you make them final. And it was an all or nothing choice. In a way, a final is the degenerate case of the sealed class concept, where we're saying, okay, no one's going to be able to subclass this. And now we're saying, no, I have some cases where I know I want to subclass this, but I don't want anyone else doing that. And we give the author of a component or an API or whatever the power to do that now, so they have finer grained control over exactly how their classes are subclassed. Okay, we also have pattern matching for the instance of operator, which lets you kind of really clean up a lot of code and make things simpler. So we can look at probably a very common idiom that we've all used a billion times here, where first off, we have some object and we don't know exactly what class it's an instance of, but assuming that, say, for example, if it's a string, then I want to use it as a string, and in order to conveniently use it as a string, I'm going to want to cast it to a string reference. So we've all written code like this, we've all seen code like this, and there's nothing inherently wrong with it, but it's just a little on the verbose side. So instead of doing all these separate things individually, we're seeing what the object is, and then we're casting that to a new variable of the type that we're interested in. We can actually pull that all into a single line here. And so we're saying, okay, so if it's a string, then within this block of code here, we will actually be able to use it as a string, and we've already given an identifier to use it. And the scope here is really, really constrained, which is nice. So if there's an else part to this, S is already out of scope in this example. So we really limit the piece of code that we're making that S a viable identifier in. And this actually lets you do neat things, like, so for example, with short circuit type behavior, where I've got my and here in the middle here. So I'm saying, you know, if this object is a string and its length is more than 5, well, we can guarantee here, because of the semantics of the language, that if we are looking at the right side of this compound operator here, that we know that that this one is true on the left side. The left part of the and is true here already. So in here, S is actually guaranteed to be in scope and be a string. And so we know that it'll work, and so we can make that part of our conditional here. In the exact same way, we can do the exact opposite with or. You know, so we can say, well, if we're looking at this, then we know that S was not the object was not a string, and therefore it doesn't make sense to talk about S on the right side. So here, this would actually result in a compiler error, because we're trying to use something that's not in scope because it was never created. And so the short circuit operators work exactly as you would expect them to, and allow you to kind of take some otherwise rather verbose and unwieldy looking code and make them much more compact and hopefully easier to read. Okay, we move into records, and records are a very exciting new part. It's probably the most generated the most interest for Java 15 for all the different preview and incubator type features. This is the second preview, so we've been doing this for a little while. But if you haven't seen records before, basically the idea is that we should be able to take classes that are data carriers. You know, their only real purpose is to contain data, like a tuple of some kind. And if, you know, traditionally, if we're just using, you know, a POJO to take this aggregate data, right? This is an algebraic data type. And so we have these two things, and well, we have to make a constructor for them, right? Because, you know, it's a class, we have to have a proper constructor. We also have to, of course, override equals, you know, because maybe we want to use these in a hash map or something like that. And then, of course, we also have to have a hash code that is appropriate and sane. And then we need our toString method, and of course, we need getters and setters of some kind or another. Well, I mean, if it's immutable, then we wouldn't have setters, but we'd have getters. And note, I'm not following the Java Bean convention here of get, blah, you know, blah, 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 but it's the same idea. So we have all this code here that is kind of almost by default, this is what you do, even though really, you know, all you really want is just kind of like a tuple, you know, where you have these two separate pieces of data and you're gluing them together to give you a product algebraic type. And so for a lot of tools that we use in IDEs and whatnot, they can take a POJO and kind of pimp it out and automatically generate this code for you, which makes writing the code, you know, not too much of a burden. But the problem is it doesn't help you read the code. And so if I'm looking at this as someone else's code and I'm looking for a bug or something, and problems with overriding equals and hash code and stuff can give you really, really ugly bugs, right? So it's really important that this code is correct, and so I have to check it if someone I don't know wrote this code, right? Or even maybe especially if it is someone I know, depending on who that someone is. But you know, I have to sanity check all this code when I look through it to make sure that it does what I think it does. So that's burden on anyone who's reading and trying to maintain this code, because it's just more places where bugs could hide. So what record does is it says, well, let's just get rid of all that. And so we can tell the compiler that, you know, I want to point, it's got these two integers, and everything else is generated by the compiler automatically. But if I'm reading the source code, now I don't have to sanity check all that other code and wonder where it came from or why it was written the way it was written. I just know that, you know, all those things that I kind of assume are necessary for this type of data carrier class are now guaranteed to be written for me and are guaranteed to be correct because it's part of the language specification. So that saves me from a lot of boilerplate. And boilerplate, as we all know, is a good place for bugs to hide, unfortunately. So anytime we can get rid of a lot of boilerplate, it's going to help us. Another thing is that I want to point out that's really important here, though, is people see this point example and they immediately think of value types because we use the same class for the same example, that we want some sort of data that represents points, made up of two individual integers. We use that same example when we talk about value types in Valhalla, and records are not value types. We're not trying to do anything with memory layout here. We're not, records are still Java objects in the sense that they have, their address is on the heap somewhere. They don't do anything for, density and a lot of the other goals that we're trying to achieve with value types are not achieved by points. And so they share some characteristics in common, like what we're hoping to do with value types is have these immutable aggregates of data, and records are also immutable aggregates of data, but they're slightly different use cases and they have different characteristics, in fact, very different characteristics in many ways. And so please don't be confused by records that that this is what value types morphed into, or this is what value types became. Value types are a different thing. They're on the roadmap, they're in the future, but they're not records. Records are something different, but records are amazingly useful and something that a lot of people are excited about because it's going to help them clean up their code and make it more readable. We also had local records added. This is new to the second preview, so new in Java 15. And it's basically the same logic that if you want to have like local classes that are, in a particular method and close to the site of their usage, for readability reasons, we can do that now with records. And by the same logic, because of some of the hoops we had to jump through to make that work, we've also extended those semantics to enums and interfaces as well. So now you can use enums and interfaces, or define local enums and local interfaces that are local to an individual method within your code. Moving on, the last incubator or preview type feature, we also have the foreign memory access API. Now, this is the first kind of product, so to speak, or the first result to come out of the major result to come out of the Project Panama, which is our effort to try and make Java interface better with the native world outside of the JVM. And so one of the problems that people have been trying to solve in various ways, going all the way back the past 2.5 decades, is how to touch or interact with foreign memory. And so, for example, I might have memory mapped files or something, as a way to access something that's on a file system, or I'm trying to talk to some other native components that I'm accessing through JNI, but for performance reasons, I want to be able to write a bunch of data to them in native memory somewhere. And traditionally, we've had two really popular ways of doing it. The Java byte NIO byte buffer, which allows you to declare what's called a direct byte buffer. And a direct byte buffer is not guaranteed, but generally speaking, is going to be off heap. And so direct byte buffer is going to be native memory that you instantiate, and then you can put anything in that you want, and then you can kind of pass pointers to that to native code, for example. Now that's certainly safe and supported and has been around for a very long time, but it's also not ideal for efficiency reasons. One of the biggest complaints is that a byte buffer, because it's managed by the JVM memory system, the native memory, when it's cleaned up, is not really explicit or guaranteed by the semantics of the current API. And so, yeah, you might be done using it and you might have gotten rid of any references to the byte buffer in your code, but that native memory might be hanging around until some future garbage collection, and who knows if you have the resources to handle that additional footprint. So that's the safe side, but maybe the less efficient. And then the other option, the other extreme, is unmisc unsafe, which kind of lets you go hog wild with touching memory in any way that you want to. And it's a very easy way to crash the JVM, because all you have to do is corrupt some memory within the JVM's address space that is important. So The foreign memory access API is our first stab at trying to give you something between these that's has the safety of a byte buffer, but is much more efficient than the byte buffer thing. So what we basically have is you can declare a segment of memory, and then you use offsets into that memory. And then so because we check those offsets against the beginning and end addresses of that segment that you allocated, we can kind of convince ourselves and prove to ourselves that the memory access that you're doing is safe and not touching the JVM internals or anything like that. So we're keeping you safe, and we're also giving you the performance that people want to see. It looks like something came up in the chat, but we're running a little bit tight on time, so I just want to keep going if at all possible. So we've also done some housekeeping stuff. We've gotten rid of a few things. So first off, we've deprecated 2 things. RMI activation has been deprecated for removal. We haven't removed it yet, but we're saying that we intend to remove this in the future, and so we really want to raise awareness that if you're still using RMI activation, now would be a really good time to migrate to a different technology or be talking to us about why you can't. We've searched around, we've looked at open source projects, we've looked at incoming bug reports from users all over the world, and activation just doesn't seem to be in use. Now I want to be really clear here, RMI is we're not talking about RMI as a whole, we're just talking about this one little part of it that's kind of obscure and really hasn't been used in a very, very long time by anybody. There is still a need and interest to be able to instantiate objects remotely, but nowadays it seems like there's, the whole industry's gone in a very different direction for how we would achieve that goal. So still things like serverless and functions as a service and stuff. There's a lot of interest in being able to instantiate objects and stuff remotely, but people aren't doing it with the RMI activation framework. So we are marking that and telling the world that its days are numbered. Also, biased locking, which was originally based off of the assumption that a lot of uncontended monitor locking happens in code. And decades ago, that was certainly the case. And so we saw very significant performance improvements when David Dice came in and kind of helped us with the biased locking implementation. So we could say that if the same thread just continuously locks and unlocks the same object, maybe we don't have to go through all the overhead of using atomic CPU instructions and all that stuff. But what's happened since then is that uncontented. Yes?
Sorry to disrupt you, but I guess we're running out of time. Maybe we can wrap up.
Okay, yep, sorry, yep. Okay, so I'll just stay with here. So we've removed the Solaris and Spark ports. We've removed Nashorn, which is that was deprecated in 11, but we will, I'll be talking about GraalVM on Wednesday, and that's kind of the replacement, or part of that feature's replacement for what we want people using JavaScript on the JDK to do. So people are interested in Nashorn and JavaScript, please listen to my Wednesday talk. And supported configurations. We haven't really made many large changes. The big thing is that we support Oracle and Linux on ARM64, and we're still investing a lot in the community and moving forward. Anyway, it sounds like we're out of time, so I'm gonna leave things here. There's just a lot going on right now. Check out inside.java to see a lot of what we're planning and doing with the 25th anniversary of the JDK, and definitely check out. We also have the Oracle Developer Live that we did last month, and so those videos are available for replay at this URL at the very bottom. And that's about it. Please reach out, talk to us. We love interacting with the community, and I really hope that you guys enjoy using JDK 15 as much as we enjoyed working on it and providing it for you. Thank you very much.
Yep. So thank you everyone for attending this session. Once again, as I said a while ago, this video is going to be up in our website, and you can always post some questions to David in case you have one. Thank you.
Thank you very much.